Can brain-derived neurotrophic factor therapy improve clinical outcomes of cochlear implantation? Adrien A. Eshraghi, MD, MSc1, Desiree Nguyen, MS1, Rahul Mittal, PhD 1. Author Affiliations 1. Department of Otolaryngology, University of Miami Miller School of Medicine, Miami, Florida. JAMA Otolaryngol Head Neck Surg. 2018 144-4, 287-288. DOI, 10.1001/JAMOTO.2017.3414. Full text. The cochlear implant, CI, is currently the standard rehabilitation strategy for individuals who have severe to profound hearing loss, HL, because elements of the inner ear and neurons are not able to regenerate spontaneously. 1. This electrode array is inserted surgically in the scala tympani of the cochlea. Sound received by the device is then converted to electrical signals, which stimulates the remaining auditory neurons, thus circumventing the malfunctioning or absent mechanosensory cells. 1. Therefore, the quality and condition of these residual neuronal structures are key factors in determining the long-term outcomes. Unfortunately, insertion of electrode array mounts host inflammatory responses, which may lead to apoptosis of sensory cells as well as auditory neurons and, consequently, loss of residual hearing. Owing to the risk of unfavorable consequences on the sensory cells and the neurons, there is a need to develop strategies to prevent damage and boost the survival of spiral ganglion neurons, SGNs. Recent animal studies too have shown that administration of brain-derived neurotrophic factor, BDNF, has the potential to improve outcomes. This can be attributed to the ability of BDNF to protect and prevent the associated degeneration of auditory neurons, particularly SGNs. In addition, a neural gap exists between the SI and the SGN semata that can influence outcome. 2. Closing the neural gap between SI and the target sensory neurons offers the opportunity to surmount current biophysical limitations of SGN recruitment. As BDNF promotes regeneration of the peripheral dendrites of auditory neurons, including SGN neurites, 3. It holds a great potential to close this neural gap by bringing the extended neurites close to this electrode array, thereby allowing more specific neural activation at lower thresholds. Furthermore, BDNF can promote the survival of SGN neurites for longer time periods that can be instrumental in improving outcomes.